right, this is part 3, or a third video, talking about quadratic functions. And again, meant for pre-calc students. This one's going to talk about how do we set up a couple of models. So like, let's say we had a parabola all set to go. So we've got a little bit of some angry birds up here, but we've got a parabola showing where that bird's going to fly through the sky here. And what we want to do is set up a standard form equation. So the form of the equation down here below, y equals a times x minus h squared plus k, to model the path, right, of that bird. Well, nicely, we know the vertex, since we laid kind of a graph over the top of this parabola. The vertex that we've identified as 5, 5, right? So we've got that coordinate 5, 5 up there. I'll throw a couple parentheses around there. And we also know another random point. We know another point on the side of our parabola. We're going to say that that's 8, 4.1 up here, right? 8, 4.1. The reason we need those 2 points is this. The vertex is very helpful. Again, standard form is often also called vertex form because h and k would help us identify our vertex. So I could start off by saying y equals a times x minus 5, because again, that was my h value, right? That was my x value of my vertex, squared, right? Close that quantity, squared, plus 5. Just so happens that the y value from our vertex was also 5. So we're already 2/3 of the way done with finding this equation. Now the downside is the harder part to find is actually that a value. We've located the vertex, but now we need to figure out sort of stretching, shrinking, and reflecting. What would a need to be in order to actually go through all of the points on that parabola? And that's where that other point comes into play. If we know one other random point, we can plug that in for x and y, and we could figure out what a would need to be for our final equation. So let's go over here to the right side of the screen, and let's do that. If y is 4.1, we would be equal to, again, we don't know what a is, but we know that the x value is 8. We know that our x of the vertex was 5, right? So we're minus 5 squared. And we knew the y value of the vertex was 5. And now if we simplify a little bit, well, that's 4.1 equals 8 minus 5 is 3, squared would have been 9 times a, and then we're plus 5 at the end. If we subtract 5, that's negative 0.9. If we just subtract 5 from both sides, and then if I divide by 9, right, we'll figure out that a equals negative 0.1, or negative 1/10, right? Negative 1/10 for an a value. And now I could go back to my equation and say, okay, well, a good final standard form equation then is y equals negative 1/10 times x minus 5, quantity squared, plus 5. And we have then our vertex form equation. Now, another way they might do this, though, is what if we don't know the vertex? What if we know 3 points? Well, notice on our graph this time, we've identified the random point. We've got our 5, 1.2, sort of that random point on our parabola. But we also happen to have our x-intercepts, 2, 0, and 6, 0. Which means even though we want to write a standard form equation, it might be much easier to start with intercept form. It may be just much simpler to say y equals a x minus our first 0, so it would be x minus 2, and our minus our other 0, x minus 6, and we've already, again, 2/3 of the way to intercept form. Now, it would be our option, like we did on the previous screen. We could take 5, 1.2, we could plug it in for x and y, and we could solve to find that a value, and that wouldn't be a bad way to go. So let's go ahead and do that, and let's figure out what a would need to sort of be for this standard form equation. And now the really nice part is that a should be the same a value, it's the same stretching, shrinking, reflecting, as it will be in our final equation. Okay? But we'll have to do a little converting, or we would have to either find the vertex or do a little converting to kind of get around that. And there's lots of ways to do that. So we'll walk through that as well. But first, let's start by saying again, 1.2 for the y value. not get ahead of ourselves. 5 for the x value. And let's find what that a would need to be. So let's do a little work. I'm going to go up here. We got 1.2 equal to a times, we've got -3 and -1. So again, 1.2 essentially equals 3a, and a is going to equal 0.4. Now I have a slight problem with that, so I need to take another look at my numbers. Oh, there's why. This should have been a +3, right? 5 minus 2 is +3, which means this is -3. Should come out to a -0.4. Now the reason I knew I had an error, remember your parabola is opening downwards right now. So that should be a negative number, right, when we find that a value. But now, as I mentioned, we have the equation then, y equals -0.4 times x minus 2, x minus 6. And if we want to find vertex form, well, as you saw in the first video, or second video, I should say, that we made within this series, what we need to do is go through basic form and kind of convert to vertex form. So I'm going to go ahead and walk through doing that real quick. Again, the first thing I would do is go ahead and expand. I need to distribute or FOIL. X times x is x squared. We'd have a -6x and a -2x, so that makes -8x in the middle, plus 12. And if we did a little bit of multiplying, -0.4 x squared minus negative, and make that plus, right, negative 3.2 x. And then again, same thing, -0.4 times 12 is going to be a -4.8, I do believe. Now we need to convert to vertex form, so we're going to isolate, again, the x squared and the x terms, and I'm going to get rid of a few things I don't really need. That -0.4, I'm actually going to factor back out, because I'd rather have this be just x squared. If I divide 3.2 by a -0.4, well, hey, it goes right back to being a -8x. I'm going to leave a little space, and I'm going to leave that -4.8 on the outside. Again, I don't really need that or the -0.4 to make a perfect square formula. So now, let's go ahead and work our perfect square here. X minus half the middle, half of 8 would have been a 4 squared, is going to be where my perfect square comes from, right? Just what's in the parentheses here. But again, x squared is up here. X times -4 times 2 is in the middle, and -4 squared would be 16. But if I add 16, I should also subtract 16, although remember, this is technically 16 times a -0.4. So I should find out what that is first. Well, that's a -6.4. So really I've put in a -6.4. So what I'm going to do, right, since that's -6.4, is I'm going to add 6.4. If I do those two things, I've balanced, right? I haven't changed my equation at all. So -4.8 plus 6.4, okay, would be a +1.6. And I'm going to carry down that -0.4 from above here. And now you'll notice we've got that nice vertex form equation. We know our a value, which as we mentioned is the same a value we had over here with the intercept form, right? Same leading coefficient, but now I'm in this sort of vertex form. If we wanted to know where the vertex was, again, x minus 4 means it's 4 units to the right, and plus 1.6 means 1.6 units up. And if we check our graph here, notice if we went to 4 and up to approximately 1.6, that definitely looks like where our vertex was. Again, if you have any questions on any of those ideas, talk to your teacher. Otherwise, again, if we went a little too quick, you might want to rewatch those first two videos. Again, parts 1 and parts 2 of quadratic functions. kind of the basics and talking about vertex form. Otherwise, have a great day.